Hello everyone, welcome to another episode of Van Amsen Explained podcast. Today we are diving into the world of computer graphics, specifically focusing on the fascinating paper titled Joint Neural Denoising of a Surface, proposed by a researcher from NVIDIA team. So the paper presents a novel approach to denoising Monte Carlo rendering in a stance containing both surface geometry and volumes. So this is a challenging task as most denoising rely on G-buffer feature guides, which are harder to define for a stance with both surfaces and volumes. And the authors propose a method that enables combining volume and surface denoising in real time from low sample count rendering. So the author's approach decomposes the rendering image into a volume and surface layer, and they use a spatial temporal neural denoise for both components. And the individual signal are then composited using learned weights and denoising transmitter. This architecture outperforms current denoiser in the stance containing both surface and volume and produces temporally stable result at interactive rate. So the paper also discussed the significant advances in denoising research over the last couple of years. Denoising are now commonly applied in a offline rendering and real-time rendering application. However, these denoising techniques often struggle on heterogeneous volumetric data such as clouds and smoke, and authors tackle this particular challenge by proposing a denoising architecture that is robust for animated stance with both surface geometry and volume data. So the author's architecture separates the input signal into surface and volume parts, denoises them individually using spatial temporal filters, and finally composite the noise signal based on volume transmit. So this approach has been previously applied to denoisers working on individual samples, but only for surface data, including volumes. And the author extended layered denoising to the spatial temporal setting. So the author also discussed the importance of temporal feedback in high quality denoising architecture, and they leverage temporal coherence in their pipeline and reprojected the previous frames using two distinct sets of motion vectors for surface and volume parts respectively. So in conclusion, the author have presented a novel approach to denoising that can handle stance with both surface and volume, and this work is a significant contribution to the field of computer graphics and could have wide-ranging application in both offline and real-time rendering. That's all for today's episode. Stay tuned for more exciting discussion and cutting-edge research in future episodes. And thank you for watching and listening, and stay tuned. And if you like it, please subscribe, and see you next time.